Okay, we'll start with number 16 on this part of the video. So on number 16, we are looking at a piecewise function again. And we are looking at the information where x is equal to 3. And now it's asked us all of these questions down here with these multiple choices. So first of all, it wants to know if f is undefined. So choice A is if f is undefined. So first let's find out if it is defined at 3. And so I want to know where x is equal to 3. That will be right here on this line. So f at 3 is going to be 6 times 3 minus 9. And so that gives me 18 minus 9, which is 9. And so that tells me that my function is defined. Okay, if it's undefined, you would have something like a 0 in a denominator or something like that. Okay, on choice B, it starts to talk about is f continuous. And so we've got 3 situations for f to be continuous. First, I need to show that my function exists, which we just did right there. Secondly, I need to talk about is it differentiable, or does the limit exist? I'm sorry, does the limit exist? And then I want to show that the two things are the same. So first of all, I want to know, does f of x exist? And in this case it does. F at 3 is equal to 9. Okay, and then I want to know, does the limit as x is approaching 3 of f of x exist? And in this case it does. I can find the limit by looking at this thing from the left and from the right. So this is going to be the left right here. So I want to know, am I approaching the same number? So let's go and find f, or the limit, as x is approaching 3 of f of x from the left. And so to do that, I'm going to plug into this equation right here, since this would be my x is going to 3. And so when I plug that in, that's going to give me 3 squared, which is equal to 9. And I already know if I plug into the right-hand side, so if I plug 3 into this one on the right-hand side, I'm going to get 9. And so since they came out to be the same thing, that tells me that the limit as x is approaching 3 of f of x is equal to 9, and so it does exist. And finally, I know that it is continuous because f of 3 is equal to the limit as x is approaching 3 of f of x. So both of them are 9. That means they're equal. Therefore, I know f of x is continuous where x is equal to 3. Okay, so B tells me that it's continuous but not differentiable. So let's look at our derivatives. And again, I'm going to need to do this from 2 different sides when I look at this. So let's start with the derivative of f of x from the left. So here's my left equation again. So my derivative of that is going to be 2x. And so the derivative of f of x, at 3, as we're coming from the left, is going to be 2 times 3, which is 6. Okay, the derivative of f of x as we come in from the right will be the derivative of this one right here. So the derivative of 6x is 6, and then the derivative of 9 is 0. So the derivative of f at 3 as we come from the right will also be 6. And so since they're the same, f of x is differentiable. Okay, so B is not the answer. It's not continuous but not differentiable. C is not my answer. I want to go all the way to answer choice E, because I've just found out that this thing is both continuous and differentiable. So continuous answers the 3 questions using the limit, and then differentiable means can you find the derivative. Okay, on number 17, we want to find the equation of a line that is tangent to y equals x cubed plus 3x squared plus 2 at its point of inflection. So the first thing I'm going to do is find out where our point of inflection is, and we can find that by taking the second derivative. So the first derivative of this thing is going to be 3x squared plus 6x plus 0. And then my second derivative is going to be 6x plus 6. So I'll have a point of inflection where that is equal to 0. Alright, so that's going to tell me that 6x is equal to negative 6, so x is equal to negative 1. So when x is equal to -1, I have a point of inflection, and that's the x value that I want to use when I fill in my line formula. So my line formula looks like this. This is point slope form. Okay, so I already know my x value, +1 right there. Okay, I can find my y value by plugging in up here to my original. So y is going to be -1 cubed plus 3 times -1 squared plus 2. So that's going to be -1 plus 3, since we're squaring right there, plus 2. So that's going to give me 4 altogether, so -4 right there. And then I can find the slope by plugging into my first derivative. The first derivative is the same thing as the slope. So my first derivative at -1 is going to be 3 times -1 squared plus 6 times -1. So that gives me 3 minus 6, which gives me -3. -3 right there. All right, it's a multiple choice question, so it does want me to solve for y. So let's move a few things around here. So that's going to be -3x minus 3, and then I want to add my 4 over to the other side. So that will give me -3x plus 1. And that is answer choice B. Okay. The second number 17 that's on there, we've got two number 17s. Oops. Second number 17 is going to deal with a natural log, and I'm going to rewrite this. We're talking about increasing and decreasing, and so I'm going to rewrite this as the natural log of x times x to the -1 power and use my product rule. You can use a quotient rule if you want to. So I'm going to say that f is the natural log of x. Therefore, f prime is going to be u prime over u, so 1 over x. And then g is x to the -1 power. That gives me that g prime is going to be -x to the -2 power, or -1 over x squared. All right, so f prime then is going to be g, which I'm going to write as 1 over x, times f prime, which is also 1 over x, plus, product rule, so g f prime plus f g prime. So f is the natural log of x times g prime, which is -1 over x squared. All right, so f prime of x then is 1 over x squared from the first, and then minus the natural log of x over x squared. And we have a common denominator there, so let's go ahead and put that together. So that will give me that. All right, so there's my first derivative. I'm going to need that a lot, so I'm going to circle it. All right, so we're talking about where this thing is increasing and decreasing, so I'd like to be able to put it on a number line and look at where these things are positive and negative. So first I want to find out where it's equal to 0 so that I know where it changes from positive and negative. I'm also going to look at where it's undefined. So equal to 0 is when we set the numerator equal to 0, and undefined is where we have the denominator equal to 0. All right, so this one's kind of an easy one. I know x is equal to 0 there. Okay, on this one right here, I need to do a little bit of work. I'm going to have that the natural log of x is equal to 1. And this is something that you probably did in pre-cal, but I know that the natural log is the same thing with the log with the base of e. And so if I rewrite this in exponential form, I'm going to have the base of e to the first is equal to x. So I have a place where we're equal to 0, where the first derivative is equal to 0, where x is equal to 0, and where x is equal to e. And e is a number that is like 2.72. Okay, and so I want to pick some numbers in all of my areas to look at. So let's say that we pick like -1 over here. And if I try to plug that in, I can't take the natural log of a negative number. If you think about your natural log graph, we have a asymptote right here, a vertical asymptote right here, and so we can't plug in negative values for our x's. So nothing down here is going to be happening. All right, let's take a look at 1. Okay, so if I plug in 1, I'm going to have 1 minus the natural log of 1. And I want to know what that's equal to. So again, this is like the log with a base of e of 1 is equal to what? So I'm going to say that e to what power is equal to 1? Well, anything to the 0 power is equal to 1, so this is like having 1 minus 0 right here, or 1. So I'm going to have a positive on the top, I'm going to have a positive on the bottom, and that's going to give me a positive right there. Okay. If you look at your graph of the natural log right here, it keeps getting bigger and bigger and bigger. So if I keep getting bigger and bigger, 1 minus that is going to give me a negative. Over something squared is always positive, and so this area is going to be negative. Alright, so if I look at my answer choices then, E is the only one that will apply because in this area right here, I know my graph is going to be, I know my graph is going to be increasing. And then over here, I know my graph is going to be decreasing, and so E says that F is decreasing for all of the x's that are greater than E. Okay, with number 18, we get into our related rates problems. So 18, we're talking about a snowball in the shape of a sphere. Our volume formula, which is this one, is given to us. And we are working at a constant rate, or the volume is increasing at a constant rate. So that's a rate of 10 inches cubed per minute. Okay, if they hadn't told me that that was the rate of the volume, I would still know because of the cubic inches right there. And I want to know how fast is the radius increasing, so dr dt is what I'm looking for, when the volume is 36 pi inches cubed. Okay, so I know I'm going to need to take the derivative of this. Let's go ahead and do that. So dv dt is my derivative of v. I'm going to use my power rule for this. So 3 times 4/3 gives me 4. Pi is a constant. R squared, and then don't forget your dr dt. Okay, so dv dt is 10. I'm going to keep my 4 pi. I'm looking for dr dt, so I'd really like to know what to use for my radius. So to find my radius, I'm going to plug this in for my volume right here. So I'm going to have 36 pi is equal to 4/3 pi times my radius cubed. So my pi's are going to cancel out, and now I'm going to multiply by 3/4. So 36 times 3/4 is going to equal r cubed. So I divided or multiplied by my reciprocal, and so that's going to give me 27 is equal to r cubed. So I'm going to say that my radius then is equal to 3. Alright, so now I can plug my 3 in right there, and I'm going to be squaring that. So this is going to give me 10 is equal to, that's going to give me 9 times 4 gives me 36 pi, and then I just need to divide over by my 36 pi. So 10 over 36 pi will be my dr dt, or my rate of change of my radius, and I can simplify that if you want to. You don't really have to, but we can simplify that, or we can leave it just exactly the way that it is. So it's going to be 10 over 36 pi, and I was working in inches here, so inches per minute. Okay, we'll start up with number 19 on the next section.